karon, 'di ba, sa alkenes, if you try to scan the notes sa alkenes na reactions, there are how many, mga 7 specific type of reactions that alkenes may undergo. So much, not more alkenes, more reactive na siya, much more reactive ang alkenes. Okay? Reactive. Okay? Now, having this idea na meron siyang multiple bond, okay, di ba merong multiple bond in a form of double bond ng alkenes, they are classified also as unsaturated hydrocarbons. Diba, recall, by structure, we can identify if saturated or not ang alkenes. Okay, or I mean ang hydrocarbons. Kapag puro single bonds, ang ga-connect sa carbon atoms or carbon and hydrogen atoms, then that is saturated one. But presence of a multiple bond in hydrocarbons, example, a double bond or a triple bond, that makes them classified as unsaturated hydrocarbon. Now, in relation to chemical reactions or chemistry ng alkenes, most of the reactions occur in this part of the molecule ng alkenes. Okay? Sa mismong double bond carbons. Bakit? Because this is the functional group. Diba? This is the functional group of alkenes. Ang carbon to carbon double bond. Now, bakit dito yung reactions most commonly occur? Recall, what is the definition of functional group? Diba? When we define functional group, this is the part of an organic molecule or an organic compound where most of the reactions occur. That is how we define functional group, diba? Kung unsa ang functional group of that particular organic compound, didto mahitabo ang chemical reaction. So for alkenes, since we are talking alkenes here, lahat ng reactions nga atong matakal, mahitabo ang reaction, ang chemical reaction sa carbon to carbon double bond. Okay? So that makes this reactive site. Ito yung reactive site. Okay? Ang site ng or portion ng alkene compounds or alkene organic molecule na very reactive. Okay? Now, during reactions, yung double bond, itong double bond part ng alkene, yung double bond between carbon atoms, this act as a nucleophile. Ano yung sabi ko kanina? What is a nucleophile? Is it electron rich or electron poor? You can type in your answer. Is it electron rich or electron poor? Yes, very good. It is electron rich. And that is very obvious man. Kahit hindi nyo alam yung term na nucleophile, if you try to check a multiple bond, what consists of a bond? Diba? A bond is consists of an electrons. Now, knowing double bond na siya, so more than 2 ang electrons in that, okay, in that portion sa reactive site ng alkenes. Okay, therefore it is electron rich. Okay, electron rich na siya nga part. The same goes with triple bond. So sa alkynes, 'di ba? Sa carbon to carbon triple bond samot electron rich na siya nga site. Okay? Sa alkene. Okay? That is why kung siya ang this part will act as nucleophile sa most of the reactions ng alkene, okay, they will react with unsay opposite sa nucleophile. Unsay opposite sa nucleophile? They will react with katong electron poor. Very good. For a while ha, for a while. Excuse me. Okay, na nanawag. Okay, sorry for that. So again, if ang alkene, the double bond part, carbon to carbon double bond part will act as a nucleophile. So therefore, yes, very good, it will react with an electrophile. So a nucleophile will react with an electrophile. That is why sa inyuhang notes, if you try to check, diba, if you try to check, yung first general reactions that alkenes may undergo are electrophilic addition. There will be an electrophile that will be added to this part of the molecule ng alkene. So, paano ba yung electrophilic addition in general? So, in general, ang electrophilic addition, that will happen via breakage first of a pi bond. So, muna yun yung dumduman. Before ka mag-add og electrophile on that part of alkenes, katong reactive site ng alkene, dire nga part, either sa uh, first carbon, double bond, or the second carbon, double bond, before ka mag-add og any electrophile, okay, electrophile, dapat you have to break first the pi bond. Bakit yung pi bond, hindi yung sigma bond? Diba, a multiple bond will consist of a sigma bond and a pi bond. A pi bond will break instead of a sigma bond because yung pi bond is weaker. Weaker siya compared to a sigma bond. Again, relatively weaker ang pi bond compared to a sigma bond. That is why electrophilic addition, kapag nag-add ka ng electrophile sa reaction ng alkenes, addition will occur by first breaking the pi bond, tsaka na yung addition reaction mangyayari. Alright? So, under electrophilic addition, there are actually 5 specific types of reactions. So, there are 5 specific type of electrophilic addition reaction. Okay? So, ang inyuhang dapat i-take note diri sa different types of electrophilic addition reaction is what electrophile is being added. Okay, what electrophile is being added or what reagent is being added for the reaction to occur. Kasi kung alam mo yung electrophile that is being added, you can easily predict the product. Okay? Kasi sa reaction, di ba, sa reaction, dapat merong reactant side and product side on the right side. Okay? So, dapat sa reactant na side, dapat alam mo yung kung ano yung reagent that has to be added, okay, in that type of reaction for you to predict the product. So, the first electrophilic addition that we will tackle is catalytic hydrogenation. Okay? So, by the term itself, kung imuha lang i-analyze ang term itself without looking with the reagents and the electrophile that will be added, kung imo lang i-analyze ang term nga hydrogenation, what do you think is being added? What gas is being added? Hydrogenation. It is very obvious. Hydrogen gas. Yes, very good. Diba, hydrogen gas is a diatomic molecule. Now, unsay pasabot aning catalytic? Ibig sabihin, the hydrogenation reaction will proceed in the presence of a catalyst. I know you are all familiar with a catalyst. Diba? Yung catalyst sa chemistry, that is very needed to speed up the reaction. That facilitates the process of the reaction. Okay? So, ano lang, hydrogenation, you are adding hydrogen gas, okay, to that alkene, kasi we're talking about alkenes here. So, ang inyong ma-encounter, alkenes plus an electrophile. So, pag catalytic hydrogenation, the reagent that you need to add is hydrogen gas in the presence of a catalyst. So, the most common catalyst that is used during hydrogenation reaction is a metal catalyst. And particularly mga strong metal catalyst. Example, a platinum, a palladium, or a nickel. Okay, again, ang purpose lang sa catalysts is to speed up the reaction. Okay? They are not being added, okay, to that reactive site ng alkene. Ang being added na electrophile is the hydrogen gas. Okay? So, specifically, ang atuang ma-add nga electrophile, the electrophile that can be produced from this hydrogen gas is 2 moles of proton. Di ba, proton is H plus. Again, asa gikan ng H plus nga electrophile, katong imong gi-add nga hydrogen gas. So, this would be the general reaction. Example, you have any alkene. So, any alkene, di ba? Any alkene will always have a double bond. Any alkene, meron niyang double bond. So, katong mismong double bond nga part, okay, yan yung reactive site, di ba? So, dun mahitabo ang reaction. Okay? Sa double bond, dito mahitabo ang reaction. Ang addition of hydrogen gas. Okay? So, again, this reaction needs a metal catalyst. Okay? Again, para lang siya mas speed up ang reaction to facilitate to support the process of reaction. So what will happen? Generally, di ba, ma-break ang pi bond, break the pi bond, so naa nakaroy unpaired. After breaking the bond, na nakarong unpaired electron ang each carbon. Kasi di ba, what composes a bond are electron. So pag break ana tagsa-tagsa sa carbon double bonds na sila'y unpaired electron. So dira para ma-stabilize ang each double bond carbon, 2 moles of H plus will be added. So isang hydrogen will be added to one carbon double bond, the other hydrogen will be added to the second double bond carbon. Okay? So from alkenes, what is the major product kapag catalytic hydrogenation? You will produce alkane. So muna siya yung dumduman. So from unsaturated, di ba sabi natin, unsaturated ang alkene. Ang major product kapag catalytic hydrogenation ng alkenes, saturated alkanes. Okay? So, ayan. So, let's have a specific example. So, very simple nga reaction ni siya kasi yung ginamit na alkene dito is the simplest alkene. Diba? This is ethene. Or, this is commonly known as ethylene. This is a common name, diba, of alkene. I mean, ethene. Ethylene. Okay? Common name of ethene is ethylene. Okay? Ethene kasi dalawa yung carbon atom, merong double bond ethene. Okay? So addition of hydrogen gas in the presence of a nickel catalyst. So this type of reaction is a catalytic hydrogenation. Okay? So breaking of pi bond will happen. Then, tsaka yung addition ng electrophile nga, H plus to each double bond carbon. So from ethene, naging alkane nga, ethane. Okay, so that is how catalytic hydrogenation occurs. Now, one of the industrial importance of this process, okay, yung catalytic hydrogenation, is in the production of margarine. Okay? Kailangan tag margarine, di ba? Kailangan tag margarine. Si margarine pala, this is being produced. Okay? Yung source niya is a fixed oil. Okay? Nga na siya pag-produce ang margarine. Kailangan mo ng fixed oil, and fixed oil are actually unsaturated. Sorry ha. Unsaturated. These are unsaturated fatty acids. And these are liquids. Di ba? Oil, fixed oil, liquid na siya. Muna siya ang source sa margarine. Pero unsa man ang texture ni margarine, hindi naman siya liquid, di ba? Solid ang liquid kasi that is already a saturated fatty acid. Okay? Ibig sabihin, yung fixed oil must undergo hydrogenation. Okay? Hydrogenation forming the saturated fatty acid, which is solid already. So that forms margarine already, for instance. Okay? So this is a saturated. So muna siya ang importance industrially ng reaction catalytic hydrogenation. Okay? Saturated fatty acid. Okay? So important din yung catalytic hydrogenation reaction. Okay, so please take note ha, yung process sa catalytic hydrogenation. Break the pi bond, tsaka yung addition ng dalawang uh, hydrogen plus nga electrophile. Alright? So let's try, for instance, this one. You are asked to write the complete equation. Pag sinabi equation, yun yung reaction. You have the reactant and the product. Okay, what separates a reactant and a product is an arrow, di ba? You have an arrow. So, obviously, the reaction here will happen to this, before na lang na siya. The reaction will happen to this part of alkene. Tama? What is being added? Hydrogen gas. So, obviously, H plus, dalawang mole ng H plus ang ma-add. So, you break the pi bond. Don't forget, good, i-break ang pi bond. Okay, manubra man ang bond, anak, kung di ninyo i-break. Malima nakabuok ang bonds around each double bond carbon kung di ninyo siya i-break. Remember, upat ra gyud ang stable number of bonds for carbon. So, break the pi bond, tsaka yung addition. Okay? Addition ng hydrogen plus. Okay? Na electrophile. So, don't forget to write also the catalyst. So, nga na lang ang pag-write sa reaction. Diba? From CH, gi-break nimo ang bond, isang bond na lang, CH to CH2, CH2. So, yan yung nangyari. Okay? Very simple kung skeletal. Skeletal structure ang gihatag. Kayo simply erase the double bond. So yun na. Kasi ang hydrogen, di ba, sa skeletal structure, imaginary. So you don't need to write hydrogen. Okay? You don't need to write hydrogen kapag nag-add ka na. Kasi nga, in a skeletal structure, di ba, imaginary yung hydrogen. So you can simply erase the double bond. And that's it. Ibig sabihin na kayo na-add-an na imaginary nga hydrogen. Okay? As the electrophile. Okay? Ayan. So, gi-delete lang niya gi-erase lang niya tong double bond here. Gi-break lang. So, automatic, ang pasabot na ani kung imaginary, nanay imaginary hydrogens being added. Okay, so that is how catalytic hydrogenation occurs. Okay? Okay, let's have another example. You are again asked to write the equation for each reaction. So, do not forget, ang alkenes reaction mahitabo sa double bond carbon to carbon. Pangitaan lang ang double bond carbon to carbon. So, diri mahitabo ang reaction. Break the pi bond. Okay, break the pi bond, tsaka yung addition ng H plus. Each carbon will be added with hydrogen plus. Okay, H plus as the electrophile. Okay, so ang mahitaboan ni, so ako siya erase, sorry. Ayan. So plus, let's say, hydrogen gas, the catalyst being added is platinum. So the product would be, ayan. You can also try it in your notes, ha. CH2, then CH2, di na masigo. CH2, CH3. Okay, so di na siya masigo. Kamo na lang dali lang, ha. Ayan. CH2. CH2. CH2, CH3. So, ito na yun. Diba? Ito yung part na to. Ang na-change. Okay? Dira na hitabo ang catalytic hydrogenation reaction. Okay? Now, second. Okay, let's have the second reaction. Okay? So, you have that alkene compound, a cycloalkene. Okay, addition of hydrogen daw. Addition of hydrogen. Okay, in the presence of a nickel catalyst. Okay. So, simply erase. Kaya skeletal man na siya. Skeletal man nga structure ang given. You simply erase the double bond. Kani siya. You simply break the double bond. Ibig sabihin, upon breaking the double bond, you are imaginarily adding hydrogen. Hiwi ako ang kuano. Yato truhon. Ay, sorry. Ayan. Okay. Okay, next. Third reaction. So, diri mahitabo ang ayan, catalytic hydrogenation. So, you add again. Ayan. Addition of hydrogen gas in the presence of a nickel catalyst. Sabi dito, nickel catalyst. So, you copy the whole structure. Ang changes lang yun is yung part na merong double bond carbon to carbon. So, CH2. Tama? From CH, you add one hydrogen for that double bond carbon. Then, single bond na lang. Then, CH3. So, madali lang, no? Yung catalytic hydrogenation. Then, add hydrogen gas for that alkene structure in the presence of a platinum catalyst. Then the product would be, kamo na ayan. Okay, gi-erase lang, gi-delete lang, gi-break ang pi bond. So, yan na yun. Okay. So, now, paano naman kapag more than one double bond ang present sa structure ng alkene. Okay? Paano naman kapag more than one double bond ang present sa alkene compound? So, let's say for instance, okay, sige, skeletal na lang. Okay? Let's have a double bond here and on this part. Okay? So, more than one ang double bond. Now, kapag nakita nyo sa reaction formula, it is being added with a hydrogen in the presence of a catalyst. Let's say, for instance, palladium, yung metal catalyst, so obviously catalytic hydrogenation. So, yung mangyayari dito, hydrogenation will still occur, okay? If you have a higher concentration of hydrogen gas. Okay? So, meron mang dalawang double bond, so you increase the concentration of the hydrogen gas. So, maklaro man na siya sa reaction. Kapag more than 1 mole ang concentration ng hydrogen gas being added, catalytic hydrogenation will proceed. Okay? So, ganun pa rin, break the pi bond, break the pi bond. Okay, so since skeletal structure man siya, you simply erase or break the pi bond here. Okay? Dili na kailangan i-add pa ang ipakita pa ba ang hydrogen. But if you prefer to really show the addition of hydrogen, it's okay. Okay, so let's have a condensed example. So say for instance, let's have CH3. So let's have CH3, CH2, CH, CH3. Sige. Ayan. Then CH3. Okay? Sige, so another alkene compound na merong dalawang double bond. Okay, tama ba no? Tama man ang number of hydrogen. 1, 2, 3, 4. 2, 3, 4. Okay, tama. So, let's say we add here a hydrogen, 2 moles of hydrogen gas in the presence of a nickel catalyst. So, what would be the major product? So, you simply break the pi bond here. Then, ganun pa rin. No? Add 1 hydrogen here, hydrogen plus molecule, hydrogen plus molecule, hydrogen plus molecule. Again ha, ang reaction mahitabo sa double bond carbon to carbon. Okay? So CH3, CH2, 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 then you have ACH. Ayan. This is CH2. Sorry. Nanubra mo niyang nanubra. Tama? Kaya na naman siya yung double bond here. Dapat CH2 lang yung nasa terminal carbon. So, CH3. Okay? So, ano lang. So, di ba nara ang part nga nag-change? This part. Ito yon, pag third and fourth carbon. And then this part as well. Ito yun. Okay, so each na dugagan lang og tag-isa nga hydrogen. Kasi doon nangyari yung hydrogenation reaction. Okay? So that is all about catalytic hydrogenation. Okay? Sige, let's proceed to the second specific type of electrophilic addition. Okay? So we have halogenation reaction. Okay, so halogenation, by the term itself, this is also known as addition of halogen. Okay, addition of halogen. Okay, and what are the common halogen gas that is being added during halogenation reaction? Ang pinaka-common nga halogen gas are chlorine gas and bromine gas. Diba? Kapag X sa chemistry, that serves or that is a symbol for halogen. Di ba, kapag X. So X2, that could be a chlorine gas or bromine gas. Okay? But between the two, ang much more reactive when it comes to a halogenation reaction is chlorine gas. That is why for most of the halogenation reaction, ang pinaka-commonly added nga halogen gas is chlorine gas. Okay? So from that reagent, we can produce an electrophile in a form of Cl chlorine ion, okay, Cl plus, or the Br plus. Okay, so ito yung mga electrophile that will be added to the reactive site ng alkene. Okay, so Cl plus pag chlorine gas ang gi-use, Br plus if bromine gas ang gi-add. So this would be the general reaction. First, yung halogenation reaction ng alkene, it may occur in the presence of the following inert solvent. So yung inert solvent, it could be a chloroform. So this is a chloroform. Common name ng CHCl3. That is CHCl3. Or systematic name, di ba, Ana, is trichloromethane. That is the same. Trichloromethane or chloroform, it's the same. Then we also have CH2Cl2. That could be another. So, or na siya. Or CH2Cl2. That is dichloro. Diba? Dichloromethane. Okay? And another inert solvent is in a form of a carbon tetrachloride. Okay, carbon tetrachloride. All this inert solvent can only be used if the added halogen gas is in a form of chlorine gas. Kasi obvious man, di ba? Ang halogen present in this inert solvent, this is inert solvent. Kung yan kag inert solvent, a solvent siya that gives no chemical reaction, no? Dili siya mo interfere ba sa chemical reaction that is happening, okay, sa mismong sample. Okay, so inert lang. Kasi what will be involved sa addition reaction is the electrophile chlorine gas, di ba? So kani sila, kanang inert solvent that only supports the reaction process to proceed. The same goes with metal catalyst, di ba? Metal catalyst, dili man sila ang muad sa portion nga reactive site sa alkene. unsa naman to sila, they will simply support, no, the activation process. Okay? The speed ng reaction process. Okay? So again ha, kapag chloroform or dichloromethane or carbon tetrachloride ang inert solvent na ginamit, make sure nga sakto pod nga chlorine gas ang being added. Kasi kapag tribromomethane, dibromomethane, or carbon tetrabromide ang gigamit, meaning ana, ang electrophile or reagent being added is in a form of bromine gas. Okay? So what will happen if the inert solvent used are the following? Chloroform, dichloromethane, or carbon tetrachloride. What will happen is upon addition of the halogen, ganun pa rin, breakage. Okay? So ayaw gid kalimti, before ang addition reaction will happen, break the pi bond. Okay, so that each carbon will now have unpaired electron. Para dira i-add ang mismong electrophile that is being used or utilized sa reaction. Okay, so naa na sila unpaired electron. And again, unsa gay ang electrophile nga ma-add? Yung mismong halogen. So kapag yung ginamit is let's say chlorine. Okay, chlorine gas. Kasi yung andito na mga inert solvent are chloroform. So obviously dapat chlorine gas. So what will being added are the following. You have a Cl here and another chlorine here. So kanang X dira, chlorine and another chlorine. That is why in general, ang major product is vicinal dihalide. Okay, dalawa kasi yung chlorine being added to each double bond carbon. Unsay meaning sa vicinal? Magkatabi. Okay? Magkatabi. Vicinal, magkatabi. Vicinal dihalide. Alright? So, again, dihalide ang product kapag ang inert solvent na ginamit are the following: chloroform, dichloromethane, or carbon tetrachloride. Kasi again, they support in the reaction process of the halogenation reaction. Particularly, gina-enhance nila actually ang concentration ng mismong halogen being added. Kaya dalawa ang na-add, dili lang isa. Dili lang sa isa ka double bond carbon may chlorine. Yung dalawang double bond carbons, okay, on that reactive site ng alkene, merong each na add na chlorine plus, okay, nga electrophile. Okay? So duha vicinal dihalide kapag merong ganitong inert solvent being added. Alright? Now, paano naman kapag ang inert solvent being added is, wait sa ha, kay naglag. Okay. Okay, what if yung inert solvent being added this time is water? Okay? Inert solvent. So, iba yung major product that will produce. Again, kapag water, di ba this is another solvent, water. And it is inert kasi it gives no chemical reaction sa mismong reactive site ng alkene. What will be added pa rin is the halogen. Okay, the halogen gas. So if water is being added as the inert solvent, I mean used to support in the activation process ng reaction or halogenation reaction, this time, isa lang na halogen or isa lang na electrophile will be added to that carbon double bond. Then yung isang carbon double bond, it will be added with hydroxyl mula sa water solvent. So, saan galing tong OH? Galing yan sa water. Kaya halohydrin. Halohydrin yung major product. Okay? Kapag halogenation ng alkene in the presence of an inert solvent, water. Okay? So, later, you will find out saan dapat yung OH ma-add. Okay? Saang double bond carbon siya ma-add. It will actually follow Markov-Nikov's rule. So later, siguro sa next nga reaction, ma-encounter na to ang Markov-Nikov's rule. Markov-Nikov's rule. Okay? Sige. So this is a good example. The simplest example, let's say you have ethene again. Diba? Ethene or ethylene, it is being added with chlorine gas. It is being added with a chlorine gas, so halogenation. Diba? Obvious kaayo. Halogen gas ang giad, so halogenation is siya nga reaction. And again, dumdumi, halogenation reaction will proceed in the presence of inert solvents. Natay duha ka klase nga inert solvent. It could be the chloro or halogen-containing inert solvent, or yung isa is water. So dito sa reaction, ang ginamit is carbon tetrachloride. So obviously, you will produce a vicinal dihalide. Okay? So you have, after breaking the pi bond, diba, each carbon will have unpaired electron. So silang dalawa will be added a Cl plus as the electrophile. Kaya ito yung nangyari. Cl plus. Okay? Now, if water is being added, ayan, water is being used as the inert solvent during halogenation, chlorination in particular, kasi yung halogen na inad is chlorine, so it could also be identified as chlorination. No? So, if isa lang ka, Cl plus will be added. Okay? Then the other double bond carbon will be added with an OH. So, isang halohydrine ang product. Again, this happens if the inert solvent used is water. Okay? So, no problem diri asa i-add ang ang chlorine kapag balikta ani nga slide. No problem ani nga structure kung asa nato i-add ang OH, asa i-add ang chlorine or ang Cl. Kasi both carbon equal ang number ng hydrogen nila. Okay, walang labis, walang kulang, the same lang. Ilang number of hydrogen. Each carbon, tagduha ang hydrogen. So, biskin asa na nimo i-add, parihara ang result. 2-chloroethanol lang gihapon ang product. Alright? And the same with this example. So, either lang. Kasi each carbon, the same lang ang number of hydrogen. So, no problem. Ayan. Ganun siya na equation. Lahat, kung inyo siyang lantawon, each double bond carbons, pantay ang number ng hydrogen. Pantay ang number ng hydrogen nila. So, no problem asa i-add ang chloro or OH. Any lang. But later, maka-encounter ta later sa number 3 para ma-realize ninyo nga naay time nga you have to consider asa gyud dapat i-add ang OH asa ang Cl. Alright? Sige. Let's have number 1. So again, these are all halogenation ha. We're still under halogenation reaction. Halogenation reaction, you're adding halogen gas. It could be chlorine or bromine gas. Chlorine gas, bromine gas, if being added, they need inert solvent for the reaction to proceed. Okay? So, sa number 1, ang inert solvent being added is carbon tetrachloride. Carbon tetrachloride. So, obviously, a carbon tetrachloride will enhance the somehow concentration ng chlorine gas. Kaya, vicinal dihalide ang product nato. Vicinal dihalide. So, kung ako i-continue ang reaction, if I will complete the reaction, the product will be, kopyahon gina ninyo tanan ang whole nga structure. Dili pwede kanira inyo i-draw nga part. Kaya naay uban student kana ra nga part ang ila i-draw. So, dili na siya whole structure sa alkene. Okay? So, the product will be, ayan, CH2, kopya ha, CH2. Then, what will happen here, you can add here the chloro. Okay? Yung isa kasi dalawa yung chlorine. So, dyan, isang chlorine, then CH, isang bond na lang, then CH, then you have another. Sa taas lang nako ibutang ha kay napay number 2. Di na nako masulat ang number 2 if kaya wala na space. So, dali na lang ang chloro. Ayan. Then, continue CH3. So, ana. So, vicinal dihalide ang product. Okay? So, ayan. Okay, next, number 2. So, madali gid ang skeletal. Madali lang ang sa skeletal. So, you simply draw the skeletal alkene, break the pi bond. Break the pi bond, lantawa unsay giad. Bromine gas in the presence of an inert solvent nga water. So meaning kung may water, isang Br, then yung isa is OH. Again, isang Br, then yung isa OH. Isang Br, then ang isa OH. So either lang, it's up to you. Okay? So pwede diri ang OH, dito yung Br. Okay? Tama ba? Sa third carbon na hitabo. 1, 2. Sa third carbon, dito na hitabo ang addition, first addition, including dion sa fourth carbon. So this is carbon 1, 2, 3, 4. So between carbon 3 and 4, di ba? Between carbon 3 and 4 ang double bond. Dapat dito rapod ninyo i-add ang mismong electrophile that need to be added. Sige. Next, chlorination. Chlorination in the presence of water. So again, isang Cl plus ang ma-add, then isang OH. So ano lang. So you draw the structure. Asa mahitabo ang reaction sa double bond. Diretso na mo sa double bond. So ano yan? Asa ani? Any lang. Any part dira nga carbon. Pwede ninyo dira ibutang ang OH, dira ang Cl. Okay? So let's say diri ang OH na ko i-place. Then diri ang Cl. Okay, after breaking the pi bond, addition will proceed. Alright? Then, finally, chlorination pa rin, but this time, in the presence naman of a carbon tetrachloride. So, somehow, ma-enhance ang concentration ng chlorine gas. That's why dalawang Cl will be added. Tagsa sila. Tagsa ka Cl for each double bond carbon. So, you draw the structure, CH3. CH. Then, you have here chloro. Isang bond na lang. Ayan. So, it's up to you sa inyong orientation sa taas ba or ubos anang carbona asan din niyo ibutang ang added electrophile. Then, CH2, CH3. So, diri nahitabo ang reaction. Ito lang yun. Muna sila nga carbon. Alright? Sige. So, that is all about halogenation. Okay, that is all about halogenation reaction. Okay, now let us proceed to the third type of electrophilic addition. Again, third type na ta ng electrophilic addition. So kanina natakol na natin yung hydrogenation, so simply addition of hydrogen. Halogenation, addition of halogen. Diba? The name of the reaction itself, clue na siya unsa ang kailangan ninyo nga reagent to be added on that particular alkene. Sige, let's have the hydrohalogenation. Hydro, so naay hydrogen. Diba? Hydro, naay hydrogen. Then you have a halogen. So, hydrohalogenation. So, somehow, ang ato ang kailangan nga reagent is HX. Diba? A hydro, then X is for halogen. So, yan yung general formula ng reagent na kailangan nating i-add during hydrohalogenation. So, specific reagent are the following acid. Hydrochloric acid, or the other one is hydrobromic acid. or this is hydrogen chloride or hydrogen bromide. Diba? You have a hydrohalogen. So what are the electrophiles that can be produced from this reagent being added? So we have H plus mula sa hydro, di ba? Siyempre, makakuha tag electrophile nga H plus. And the other one is the halogen. Depende on sa ginamit nga halogen. Kung ang ginamit nga halogen being added, hydrohalogen being added is hydrochloride. So, ang atong ma-add nga electrophile is H plus and Cl plus. If hydrobromic acid ang gi-add nga reagent during hydrohalogenation, ang atong ma-produce nga electrophile are H plus and Br plus. So, magdepende na siya sa reagent nga gi-add. So, this would be the general reactions. Okay? So, general reaction, you have an alkene. Any alkene. So, again, sa any alkene, ang reactive site is the carbon-to-carbon double bond. Now, upon addition of a hydrohalogen, it could be hydrogen chloride or hydrogen bromide. Usually, this occurs in the presence of ether, by the way. Okay? Yan yung usual solvent na ginagamit. Again, ang solvent lang that supports the reaction for it to proceed. Ang atong main gyud nga inyuhang dumduman permi is unsa nga reagent or electrophile that has to be added to that alkene. Okay, so what would be the product upon hydrohalogenation? It will produce an alkyl halide. Diba? You have an alkyl group and you have a halogen. Okay, so meaning, ang imuhang makuha nga electrophile, that will be added to each double bond carbon after breaking the bond. Isa is a halogen, the Cl plus ba or the Br plus. And yung isa is an H plus. So ito yun, H plus or either then ani Cl plus or Br plus. Depende unsa ang gi-add. Kung kaniba or HCl. So ana lang. Again, ang ma-add nga electrophile kapag hydrohalogenation based sa gi-add itself, di ba? Hydrohalogenation ay H plus, then na ay halogen. Okay, kaya na kay halogen, it could be Cl plus or Br plus and DH plus. Okay? In general, that is an alkyl halide. Na yung tanong, asa man ma-add ang chlorine, asa ma-add ang hydrogen, asa nga carbon ani sa carbon double bonds, carbon to carbon double bonds. Okay, in order to predict the major products in here, you have to follow Markovnikov's rule. Again ha, ang atong pangutana karon, unsaon na to pagkabalo kung asa i-add ang X, asa ang H i-add. Kasi these are different electrophiles. One is at its highest priority. Ang isa hindi masyadong priority nga atom, di ba? Ang hydrogen, it is not a priority group. So asa na itong ma-add each sila? So we have to follow Markovnikov's rule. Ang Markovnikov's rule, this was actually proposed by Vladimir Markovnikov. Usa siya ka Russian nga chemist. He was the one who formulated an empirical rule to predict the outcome of some addition reaction. So example ana is during hydrohalogenation reaction. Para dali ra nato ma-predict ang major product, we follow his proposed rule. Okay? So asa padulong ang hydrogen? Di ba itong pangutana, asa padulong ang hydrogen, asa padulong ang X gikan sa hydrohalogen nga gi-add. Okay? Let's say for instance, ang gi-add is HCl. During hydrohalogenation, asa padulong ang H, asa padulong ang halogen nga Cl. Okay, take note, hydrogen will be added to the carbon with greater number of hydrogen substituents. So lantawon nato tong carbon to carbon double bond nga part, di ba dira mahitabo ang reaction. Lantawa, i-compare kinsa ani nga carbon, i-compare kinsa ani nga carbon ang greater ang number ng hydrogen substituent didto nimo i-add ang hydrogen. Iuban nimo kung asa ang mas daghan nga hydrogen substituent didto siya padulong ma-add nga carbon. Okay? So kung alam mo na saan papunta si hydrogen, no problem na dayon kay X. Dito siya sa isa, ka double bond carbon. Kung saan, yung carbon na yun, lesser ang number of hydrogen. Okay? Again, sa Markovnikov's rule, in order for you to predict the product, hydrogen will be added to the carbon with greater number of hydrogen substituents. The X or the halogen will be added to the carbon with lesser number of hydrogen. So let's say, for instance, a specific example here, you have this alkene added with hydrogen chloride. So this is hydrohalogenation. So yung tanong, asa padulong ang H plus and the Cl plus nga electrophile. Okay? So you compare between these two double bond carbon, sino yung mas marami? Yung hydrogen. Ang isa, CH lang. Okay? Itong carbon na to, CH lang. Yung carbon na nasa kanan, yung nasa right side, CH2. So, mas marami yung CH2. Therefore, on that carbon, dira na to i-add ang hydrogen. Dito siya padulong ang hydrogen. Okay? So, for this carbon, dira ma-add ang chlorine. So, that is all about Markovnikov's rule. The same will go to the previous reaction, which is all about sa tong previous reaction, halogenation in the presence of water. Alright? Diba, ingon ko kaganina, in this reaction, halogenation in the presence of water, if hindi equal yung number of, if hindi equal yung yung number ng hydrogen for each double bond carbon, then you follow Markovnikov's rule. Yung OH specifically, it will be added, okay, it will be added to the carbon with much more substituted. Okay? Kung yun kag much more substituted, much more alkyl groups, ba? Mas daghan siyang alkyl groups. Okay? So, wala siyang masyadong hydrogen. Okay? Sa carbon nga wala masyadong hydrogen, doon i-add yung OH. Okay? During halogenation in the presence of a water inert solvent. Okay? Sige, balik ta. Dere. Okay? Let's have the following example, for instance. Okay, again ha, atong i-wrap up. Markovnikov's rule during hydrohalogenation, ang hydrogen dito padulong sa double bond carbon nga greater ang number sa hydrogen substituent. Okay? So katong isa ka carbon nga lesser ang hydrogen substituent, dun papunta yung halogen as the electrophile. Sige, I will predict now the product. Okay? So, I will copy first the structure. What is being added? Hydrogen bromide. Again, what is being added is hydrogen bromide. So, before the addition will take place, pi bond will break. Okay? You have to break the pi bond bago yung addition mangyari. So, diri yung double bond carbons. Muna siyang involved. Muna siya ang mga reactive site ng mga carbon. So to stabilize those carbons, you have H plus and a Br plus that will be added. So asa padulong ang H plus? Question, asa padulong ang H plus? Is it sa carbon letter A or carbon letter B? Carbon letter A or carbon letter B? Asa padulong ang H plus? What do you think?
Okay, ma'am.
Wait, ha. Ako di. Ay, na-erase. Kadali lang. Okay? So, asa padulong ang H plus. Again, inyong answer is sa carbon A. Okay, ano yung sabi sa Markovnikov's rule? Di ba, Markovnikov's rule, dapat doon sa carbon nga more ang hydrogen. Alright, very good. Sa carbon B. Di ba, this is a structure, skeletal structure. Obviously, this carbon here, diba, after breaking the pi bond, okay, this carbon here, actually wala siyang hydrogen. Kung dili pa ka mag-break, kung wala pa kay i-break, di ba? Kung imo i-compare, kani nga carbon, wala na siya hydrogen actually. Kani nga carbon, si carbon letter A kanina. Wala siya hydrogen. Kasi, kani nga carbon na siya complete 4 bonds. CH3 towards another carbon. And kaning double bond, this is a total of 4 bonds for that carbon. Whereas, kani nga carbon, letter B, na siya imaginary nga, isa ka-hydrogen. Diba? Kaya na naman siya, diba, sa skeletal niya nga structure na siya 1, 2, 3. Tama? 1, 2, 3 nga bond. So, imaginary ana is actually a hydrogen. So, between A and B, ang naalay hydrogen dire is si B. So, dira padulong ang H+. So, you add here. Pwede na nimo dili ipakita ang H+, kung skeletal structure. Diretso na ka sa BR. So, diri padulong ang BR. Okay? I hope inyong nasabtan ha. Baliki ang Markovnikov's rule. The H plus will be added to the carbon na greater ang number ng hydrogen. So, automatic, ang halogen, dito siya sa lesser or wala gyud, lesser or walay hydrogen. Alright? Sige, let's continue. Number 2, this is addition of hydrogen chloride. So, ang ato ang ma-produce ani nga electrophile are the following, H plus and Cl plus. So, asa padulong ang H plus. So, compare nimo, kani nga carbon wala siya hydrogen. Kay di ba naa daw siya duha diri ka CH3. So, na siya CH3, CH3 plus a double bond, upat na ka bonds niya. Okay? So, 0 hydrogen substituent. Whereas, this kani nga carbon highlighted with color red, na siya dalawang hydrogen. So, obviously, carbon, double bond carbon on the right side, dito padulong ang hydrogen. So, you copy the whole condensed structure, CH3, 2, then, dito mo i-add yung chloro, one bond na lang, then CH3. Don't forget yun, basta addition reaction, break the pi bond. Dili ka pwede mag-add kung wala na break ang pi bond. Alright? Ayan. Sige, continue. Number 3. Okay, number 3, compare again which of this carbon sa reactive site ang more hydrogen, obvious kaayo. On the left side, isa lang. On the right side, dalawa. Okay? Again ha, ang mag-involve lang yun sa reaction is katong double bond carbons. Double bond carbons. Lantawa, pila ilang hydrogens, kadaghanon sa hydrogen. Dito padlong ang H+. Okay? So, this will become, the major product is CH3. Ayan. CH3 padulong ang Cl. Okay? Isa na lang ka bond, then CH3. Alright? Then, for this skeletal structure, number 4, obviously, kani nga carbon na akong gi-highlight with color orange, wala na siya hydrogen. Upat na ka-bonds nag-surround sa iya. Double bond, then kanida yun. Double bond, then kanida yun. So, upat na kabuok. So, wala siya hydrogen for this carbon. Alright? So, hydrogen will be added to this carbon, kanang encircled carbon. Okay, so that is all about hydrohalogenation. So, dali ni mo i-add ang BR. Okay. That is all about hydrohalogenation. But there are cases na the same ang number ng hydrogen substituents for that double bond carbon. Let's say, for instance, for example, case number one, this is case number one. What if the same for both double bond carbon, the same ang degree of substitution ng hydrogen. Say, for example, CH3, CH2, then CH, then dito then CH. Di ba? Parehas sila ng degree of substitution ng hydrogen. Okay? Then let's say the added hydrohalogen is a hydrogen bromide. Okay? Then you are asked to predict the product. So asa karon padulong ang H plus, okay, nga atong makuha from hydrogen bromide, asa padulong ang Br plus nga mga electrophile. So in this case, since the same ang degree of substitution ng hydrogen, you can have two possible mixture of addition products. Diba? So imong i-provide ang duha ka possible nga product. Bisken asa, diba, nimo i-add ang hydrogen. So sa isa ka product, pwede nimo i-add ang hydrogen sa kaliwa. Sa second nga product, pwede ang hydrogen doon sa kanan nga double bond carbon. Kasi nga, parehas lang yung degree of substitution. So, dalawang mixture of products ang imuhang makuha. So, CH, pwede din mo i-add ang hydrogen. So, maghimo siya CH2. Then, there is a second sa right side nga carbon, double bond carbon, dira ang bromine. So, pwede. Or the other, dili siya or, and the other product is CH3, CH2, then diri ang Br, then sa pikas na pud nimo i-add ang hydrogen. Okay? So mixture siya of products kasi nga the same ang degree of substitution ng hydrogen. Dili nimo ma-apply ang Markovnikov's rule. Kaya di ba sa Markovnikov's rule, dapat ang hydrogen dito padulong sa greater number of hydrogen substituent. Where in this case, di ka makakompare kay parehaman sila og number ng hydrogen. So both, either ana dito ka mag-add sa hydrogen, H plus, sa H plus. Okay? So duha ka possible mixture of products. So that is case 1 nga inyuhang dapat i-remember about hydrohalogenation. Case 2, this is another case. Okay, case 2. If you encounter a reagent, if the reagent being added is hydrobromide, specifically in the presence of an alkyl peroxide. Again, this is another case nga you have to remember. Okay, under hydrohalogenation. If the reagent being added is hydrogen bromide in the presence of alkyl peroxide, example, ang pinaka-simplest nga alkyl peroxide is, di ba, so yun ang panghinlo sa ears, kanang hydrogen peroxide. Di ba, familiar mo sa hydrogen peroxide? Ayan, hydrogen peroxide. So if ever, kana nga reagent ang imuhang makita sa reaction, then what will happen here is anti-Markovnikov's rule will be followed. Okay? You have to follow anti-Markovnikov's rule. Ano meaning sa anti-Markovnikov's rule? Baliktarin mo lang. Baliktarin mo yung Markovnikov's rule kanina. Di ba ang Markovnikov's rule kanina, hydrogen, it will be added to the carbon kung saan marami yung hydrogen substituent. So kung anti-Markovnikov's rule, ang hydrogen this time will be added to the carbon nga lesser ang hydrogen substituent. So baliktad. Baliktarin nyo lang, that is anti-Markovnikov's rule. So bakit anti-Markovnikov's rule? Ano yung nangyari? Si alkyl peroxide kasi, it will try to counteract the, let's say, the regioselectivity of the electrophile being added. So, kumbaga, it causes a peroxide effect. Iyahang gina-counteract ang selectivity ng electrophile being added. So let's say for example, the structure of alkene is this condensed structure, CH2. Okay, then added with hydrogen, bromide, and inyo makita sa reaction, okay, it is added with hydrogen peroxide. Okay, that is the simplest alkyl peroxide ha, or this is H2O2. Parera na siya. So again, ang atong electrophile nga ma-produce ani is H plus and Br plus. But since the reaction here, upon addition of hydrogen bromide, na ay presence of alkyl peroxide, yung gagawin ni alkyl peroxide, iyang i-counteract ang selectivity ng electrophile being added. So anti-Markovnikov's rule. So when you compare here the carbon, double bond carbons, kung saan yung lesser hydrogen this time, lesser hydrogen substituent na carbon, doon papunta yung hydrogen. Kasi nga anti-Markovnikov's rule. Baliktad. Okay, so that is case number 2 na inyuhang i-remember. Again, those only take place if ang added nga hydrohalogen is hydrobromide in the presence of alkyl peroxide. So yun lang yung dapat nyong i-remember. So CH3, this will become CH3. Then CH2, then isang bond na lang. Then CH2, what is being added here? Br. So diri napadulong ang Br. Okay, Br plus. So, kabaliktaran ng Markovnikov's rule. So, please do remember these cases. Case number 1 and case number 2 under hydrohalogenation. Okay? So, pag makakita mo sa reaction, okay, na ay hydrogen bromide ba or hydrogen chloride, automatic, hydrohalogenation yan. Ang electrophile nga imuhang makuha out from that is an H plus and Br plus. In order for you to predict the major product, okay? If wala kay makita ha, wala kay makita nga alkyl peroxide. Ana lang, normal lang nga addition nga hydrogen, hydrohalogen. Okay, so ang major product, you can predict that via following the Markovnikov's rule. Kung asa mas daghan nga hydrogen substituent, nga double bond carbon, doon papunta yung hydrogen. Okay, the H plus. Pero, if applying case number 2, if it is hydrohalogenation using hydrogen bromide in the presence of alkyl peroxide, anti-Markovnikov's rule dayon ta. Now, if dili ma-apply ang Markovnikov's rule, kasi nga the same ang degree of substitution of hydrogen in both double bond carbons, then you will produce a mixture, no? Mixture of products. You have to provide the mixture of products. So that is all about hydrohalogenation. Okay, let's proceed to hydration. Okay, tell me, kung mag-hydrate ka sa imong body, unsa ang solvent nga imuhang ginainom? Hydration. What do you think is being added kapag hydration sa reaction? Very good. Water. Di ba? Kung mag-hydrate ka, you're adding water. Okay? Magkaiba yung hydrogenation sa hydration. Kasi hydrogenation, hydrogen gas. Hydration, water is being added. The H2O is being added. So, ang reagent dito is H2O. And take note, this type of reaction commonly occurs during acidic condition. Okay? During acidic condition. That is why, for hydration reaction, it always occurs in the presence of an acid catalyst. Kasi at acidic condition man, so dapat na ay always acid catalyst. Okay? That will be the source of H+, ang acid catalyst. Okay? So, ang electrophile nga ato ang ma-produce out from that reagent is the H+ coming from the acid catalyst and the OH coming from the water being added. Okay? Ang pinaka-usual nga acid catalyst ginagamit is disulfuric acid. Okay, so inyong nang maklaro kapag hydration, na kayo makita plus H2O, then sa arrow, na kayo makita nga acid in a form of sulfuric acid. That is hydration. Okay, that is hydration reaction for alkene. So, this would be the general reaction. You have an alkene added with water kasi nga hydration. In the presence of an acid catalyst, what will happen again? Unsa nga electrophile ang ato ang makuha? H plus and OH. Now, asa karon i-add ang H, ma'am? Asa i-add ang OH? Follow again Markovnikov's rule. Okay? Follow. So, very important yun si Markovnikov's rule in deciding, in predicting the product. Markovnikov's rule. Again, asa padulong ang H didto karon sa carbon nga greater ang number ng hydrogen substituent. And OH doon sa lesser. Okay, lesser ang hydrogen substituent. Okay? Sige. Let me have this equation. Let me answer only 1 and 2. Okay? Para ma-finish na to ang whole nga topic. Okay? Sige. Let me answer number 1. Hydration. Hydration in the presence of acid catalyst. Again ha, ang ato ang electrophile that will be produced out from this reagent is an H plus and an OH. Okay? So follow Markovnikov's rule. So this becomes CH3. Excuse me. CH, then dito padulong ang OH. Kay lesser man, kani nga carbon, lesser ang iyahang hydrogen substituent. Then CH3. Okay, number 2. That would be the major product, ha? And by the way, tell me, what do you think is the functional group present sa major product? Sa hydration, what is the major product? Yes, very good. Alcohol. Kaya di ba na ay OH? Alcohol ang major product. Muna yung dumduman, hydration, alcohol ang major product. So number 2, continue ta. Copy the whole thing, copy the whole structure, CH3. So between this carbon, obviously, ang naalay hydrogen is this one. Diba? So dira padulong ang H. Okay, so okay lang nga dili na ipakita ang H kasi nga this is a skeletal structure. If you prefer to write H plus H, then it's okay. Okay? So then dito yung OH. Okay? So please continue number 3 and 4. Sige. So we're done with electrophilic addition reaction. Done with electrophilic addition. Let me finish the discussion so that dili ma-behind ang block B and C. Okay? Gamay na lang ni. Okay, oxidation reaction. We're done with electrophilic addition. Let us proceed to another general reaction that alkenes may undergo. We have oxidation. So general idea, when we talk about oxidation, di ba? Oxidation. What do you think is the atom nga being added kapag oxidation? Oxidation. What do you think is the atom being added? Very good. Oxygen. So kapag oxidation, you are adding here oxygen. Addition of oxygen atom to a molecule, usually in a form of hydroxyl. Okay? Or this is simply removal of hydrogen. It's the same thing. Okay? Kung oxidation gani, in general, that is addition of oxygen or removal of hydrogen. So there are 2 specific types of oxidation reaction. We have hydroxylation, or this is also known as glycol formation. So these are the reagents that is needed. Okay? Of course, since we are dealing here oxidation reaction, kailangan natin ng source of oxygen. Kailangan natin ng source of oxygen. Okay? So kailangan yung mga oxidizing agent. Okay? Oxidizing agent. I think you're familiar with oxidizing agents. Okay, so sila yung sources natin for the oxidation reaction to occur. So for hydroxylation reaction, take note, hydroxylation reaction, this occurs via treating the alkenes with a cold. Take note, kailangan yung solution is cold. Okay, bugnaw na solution. And dapat ang reaction or ang sample is in a basic environment. Basic environment or let's say neutralized yung environment. So meaning ang potassium permanganate that is being added, ang potassium permanganate which is the oxidizing agent, okay, it has to be in a cold solution and basic environment. What are examples of bases? Di ba? Example ng bases is sodium hydroxide, yung may mga OH, di ba? Those are bases. That is why sa general reaction, meron ka makikitang oxidizing agent ka potassium permanganate, okay, in the presence of a sodium hydroxide, that this will tend the reaction basic. Okay? Kasi sodium hydroxide is a base, then cold solution. Muna siya inyong dumduman, basta hydroxylation. This occurs in the presence of an oxidizing agent. The most common oxidizing agent being added is potassium permanganate. Siya yung magiging source ng oxygen, obvious man sa iyang reaction, sa iyang formula, di ba? Meron siyang O4, very rich in oxygen. Okay, so siya yung source ng oxygen to be added. Particularly, ang electrophile nga ato ang ma-add since this is hydroxylation, OH. Okay? OH ang ma-add upon breaking the pi bond, OH ang ma-add to each double bond carbon. So, ganun lang. Yun lang yung i-take note nyo for hydroxylation reaction. Okay? Kung namoy makita nga reagent, potassium permanganate in the reaction, plus cold ang solution, basic ang environment, okay, upon breaking the pi bond, OH ang ma-add OH. That is hydroxylation. Okay? That is why vicinal diol ang major product. Okay? Vicinal, magkatabi yung addition ng OH or hydroxyl. Or this product in general is a glycol. Okay, ang pangalan ana nga structure is a glycol. Okay, that is why glycol formation also ang iyahang other term sa reaction. Kasi nga yung major product, you are forming here a glycol or a vicinal diol. This is just a byproduct. It's up to you if you write this upon predicting or writing the equation. It's up to you. This is just a byproduct ng visible bitaw nga result kung imo ni siyang i-undergo sa laboratory nga experiment. Okay, ang imong makita kung imo ni siyang i-test, kuan man gani siya test also to determine if unsaturated ba ang sample. Okay, this reaction can be used to test if unsaturated ang sample. So, kung positive nga result, okay, positive result, ang imong makita is a brown precipitate. Okay, that is just a visible result. Ang major product natin is the glycol. All right? So additional information na siya. This is actually a Bayer's test for unsaturation. Now, in some other reaction, aside from potassium permanganate, okay, or instead of potassium permanganate, they usually use they usually use osmium tetraoxide. Okay, so pwede ka na ang gamiton instead of potassium permanganate. Then sodium hydroxide gihapon ang basic ang base nga ginamit to make the environment basic and cold pa rin yung solution. So that is all about hydroxylation. Okay? Sige. And this would be the last reaction under alkenes for oxidation. Okay, the oxidative cleavage. Okay, so this is the exact opposite actually of hydroxylation. Kasi sa hydroxylation, kailangan mo ng potassium permanganate in the presence of basic environment and cold solution. This time, kapag oxidative cleavage, yung reaction will happen in the presence of an oxidizing agent, specifically potassium permanganate, but this time in the presence of acidic environment. So, kailangan ng acid. Okay? And take note, hot environment. Di ba kanang delta sa reaction? That specifically symbolizes heat. Okay? So, exact opposite. So, kung makita niyo sa reaction, okay na potassium permanganate, acidic ang reaction kay na ay, let's say, sulfuric acid. Okay? Sulfuric acid usually good ang ginagamit as acid catalyst. Then, na ay heat. Gi-undergo heat ang reaction. Then that is oxidative cleavage. So what would be the general product? So this would be the following general product. You may produce a carbon dioxide, or you may produce, what is RCOOH? Tell me. Type in your answer. What is RCOOH? Okay, very good. Carboxylic acid. And the other one is, this is not RCOR, ha? That should be ketone. Okay, RCOR lang. Okay, R, then CO, then R. It should be ketone lang. Okay, RCOR. Alright? Then again, this is just a byproduct. So it's up to you if you write it. Ang ako lang yung pangitaan is a major product. So unsaon man nato pagkabalo, ma'am, nga carbon dioxide ang product? Unsaon nato pagkabalo nga carboxylic acid? Unsaon nato pagkabalo nga ketone ang product? Okay, please listen. Sabi dito, oxidative cleavage. Imagine na tanan cleavage nga inyuhang naibalan sa inyuhang mind. Okay, sige, ingana na lang ang inyong imagine. So mag-cleave ni siya. Okay, mag-cleave. Matunga. Di ba kung cleavage, tunga man na. Matunga, cleavage. Okay? So matunga na siya nga part, reactive site sa alkene. Okay? Mahati siya, ma-cleave out. Now, in order for you to identify if carbon dioxide ang product, imong lantawon ang cleave part. Okay, ang cleaved part. Say for example, take note, if one of the cleaved portion is, ang cleaved portion ba? Pag cleave nimo, kani nga portion, ang naa sa iyaha is CH2. Okay? If one of the cleaved portion, either kaning nasa right or nasa left or nasa right, CH2, then that part becomes carbon dioxide. Kasi that portion nga naay hydrogen, that is highly oxidative. That's why mahimo siya CO2. Okay, ma-oxidize ang hydrogen. Kaya instead of hydrogen, na-oxidize siya, naging CO2. From CH2, naging CO2. Okay? If the other cleaved part, you have to listen, ha? If the other cleaved part is, gamay lang yun. Let's say, a carbon here, ang cleaved part niya is, ang isa R group, na ay direct attachment to a carbon, di ba? That is R group. Then the other one is hydrogen. Kana nga part ang mahimog carboxylic acid. What is a carboxylic acid? Diba carboxylic acid is RCO. Then kaning hydrogen nga part, siya yung ma-hydroxylized. Okay? The carbon and the hydrogen part, ma-oxidize sila. Okay? So RCOOH na parehas ra na sila, ha, sa RCOOH. Mura ni siya. Again, kapag ang isa ka cleave part after cleaving na ay isa ana nga part, ing-ani yang itsura generally na ay R group, then ang isa na siya isa ka hydrogen, kana ang mahimog carboxylic acid. Okay na tana. And lastly, if diri na lang sa taas na ko ibutang, ha, color orange. If ang isa ka cleaved part, puro R group ang naka-attach, this is also possible, di ba? Puro R group, this now becomes a ketone. Siya yung magiging ketone. Okay? Di ba? That is a ketone. RCOR. Maura na siya. RCOR. Alright? Sige. I will try number 3. Okay? Sige, I will try number 3. Then it's your part na dayon ang number 1 and 2. Okay? Sige. So, let me cleave the reactive site ng carbon. Okay, reactive site ng carbon. Again ha, the reactive site is yung double bond carbon to carbon. Imo siyang i-cleave. Hatiin mo siya. Okay? So, ang imuhang makuha ani, you have a cyclohexane. Then, di ba mauni ang cleaved part sa usa? Okay? The other cleaved part, ato sa i-compare, the other cleaved part is a CH2. Let's say, ako na siyang i-change. Ako siyang i-ani. Maura na siya ha. Maura ni siya. CH2. Di ba CH2 ang other cleaved part? Maura na siya. Ako lang siyang gipakita in a Kekulé form. Okay, CH2. Okay, you have to um, determine each cleaved portion para makabalo ka kung mahimo ba siya carboxylic acid, ketone, or carbon dioxide. Okay, this carbon. Okay, from this cleaved part, anong sa balik ta diha? From this cleaved part. Okay? Kung puro R group ang naka-attach sa iya from this cleaved part, kung puro R group, siya ang mahimog ketone, which is maong nahitaboan ni dire. Okay? In this cleaved part na kay carbon, di ba dire? Carbon. So R group na sila. Therefore, this will become a ketone. How do you write ketone? Lantawa yung cleaved part. Ma-oxidize ang carbon. Okay, ma-oxidize ang carbon. So you simply add O here. So ano lang. That becomes a ketone. Okay? Yung isang cleaved part is a CH2. Ano yung mangyayari sa CH2? Mahimo siyag CO2. Okay? So this becomes CO2. Kasi yung hydrogen nga is highly oxidative. Okay? So CO2. Any R group, they are not prone to oxidation. Kaya, retain lang sila. Pero pag may hydrogen attached to that double bond carbon, automatic that will become oxygen kasi highly oxidative sila, prone to oxidation. Sige, let me answer number 2 na lang. Kamo na ang number 1, pinaka-simple ng number 1. You have to draw first the structure of 2-methyl 2-butene. Okay? So, sabi dito, butene, so 4 na carbon, nasa carbon 2 daw ang double bond. Sa carbon 2 na ay methyl. Last na ni ha. So continue by adding hydrogen, CH, then CH3. So that is 2-methyl 2-butene. The reaction, these are all oxidative cleavage, no? Oxidative cleavage kasi merong acid catalyst, then application of heat. Okay? So I will continue here, no? So as if na lang add potassium permanganate in the presence of. So I will predict the product. So i-cleave lang ninyo, cleave. Then determine this carbon, ano ang meron naka-attach sa kanya? CH3, another CH3. These are R groups. So kana nga part mahimo og ketone. 'Di ba? So ana lang ni siya. Diba, mo ni siya ang CH3. Then this part na po siya CH3. Okay? So yun lang. Then the other product, you have to determine this part. Kani nga carbon na siya isa ka hydrogen. The other one is an R group in a form of CH3. Again, yung isa is hydrogen, ang isa R group. So this part becomes not CO2, not ketone, but carboxylic acid. So para inyo yung ma-imagine akong awaton gyud giunsa na siya pag cleave, di ba? Nadiri ang part nga cleave. Kay nara ang carbon nga color red, gi-highlight as color red mo na siya. Kaning hydrogen nga part, ma-hydroxylize siya kasi ang hydrogen prone again to oxidation. Then retain the R group, oxidation of the carbon. So that is carboxylic acid, RCOOH. Okay? So in reaction number 2, you have produced there a specific ketone and a specific carboxylic acid. Okay? So those are the overall the reactions that alkenes may undergo. Okay, so you may continue number 1, ha? Okay, you have any questions?